done, we have prepared the ETAB model, we have done the analysis, and we have done the design. Okay, and in today's session, what we will learn how we can see the all the results, how we can see the results. Okay, so we have designed the building. Okay, so every member is passed the design check. Okay, let me keep you. Okay, let's do the again. Okay, let's do design again right now. So you can see the results here. Okay, so let's go to the concrete frame design and verify all number passed. So here you can see all the concrete frames pass the design check. Okay, so suppose I want to see the results for the column only or beam only. So what we will do, I will go to display design info. Okay, and here I will choose total longitudinal reinforcement apply. Okay, so total rebar percent. If I want to see all the results in percentage, so I can go to total rebar percentage and apply. Okay, and here let's go to plan, and let's go to plinth level, apply. Okay, so here you can see the all the beam reinforcement in percentage. Okay, so here you can see every reinforcement is in it's I think minimum 0.21, 0.51. Okay, let's go to the above story at the first floor. You can see we are getting only minimum reinforcement. Okay, let's go to above also. Here also you can see we are getting uh, less than 1%. Okay, so it's kind of economical design we are doing. Okay, so here also so every at every beam we are getting less than 1% reinforcement. Okay, so suppose I want to see the reinforcement for the column. So what you can do, you can draw elevations, and you can see all the columns reinforcement. So here what I will do, I will go to the draw, and draw developed elevation column. Okay, so what we will do, we will take this grid. Okay, so we will go to our framing first, and here you can see this is the grid 03. Okay, this is the 03 grid. So what you can do, you can write column elevation and at the rate grid 3. Okay, so let's write 3 here. Okay, and okay, and now we will select all the column at the grid location 3, and enter, press enter. Okay, you elevation here, and you will apply at the total rebar percentage. Let's apply it. So you can see the results here. Okay, so here you can see we are getting reinforcement in college 1.61, 2.53, 2.8, 1.79, 1.52, 1.45. Okay, so that's how you can see all the column reinforcement. Okay, and there is also another way in which you can check the reinforcement. Okay, so if you will go to this display show table and concrete frame design output, and here is the concrete frame summary data. Okay, so in the concrete frame detail data, here you can see concrete column PMM envelope. Click here and click OK. So let's click here. Let's right click here and press sort descending. So here you can see the maximum reinforcement, it's 2.99, and you're getting this reinforcement is in C17. Okay, so that's how you can see all the results also for the column reinforcement. Okay, and for the beam reinforcement, you can see the plan, every plan, like plinth level, first floor, second floor. Okay, So this is the data. You can see the maximum reinforcement is 2.99. So if in the column, if your percentage, the reinforcement percentage is ranging from 2 to 2.5 or 3. So you are doing kind of economical design. Okay. So what you can do, like let's go to clear short. Okay, let's do clear short, and you can copy these data. You can copy the data and you can go to Excel, and you can open new Excel. So let's paste all the data here. Okay, so you can see you are getting all the data here, and these are the labels. Okay, these are the column labels also here. So if you want to see the column labels in your ETAB model, so what you can do, you can go to the plan, you can go to plinth, apply, and let's go to set display option. Here select object assignment. Okay, so here you can see, so our view, I want to see the labels of the frames. Okay, so this is the frame assignment, and let's click label. Okay, and apply it. uh, so you can see we have assigned all the labels. Okay, so here what you can do, you can uh, you can hide the beams. Go to the select object type, select beams only here, and right click, show hide selected object. Okay, so here you can see you are seeing all the labels. Okay, you can see, so these are the labels here. You can see all the label for the column. Okay, and as per the labels, you can see the corresponding reinforcement in this same table. Okay, here you can see the section also, what sections size you have assigned for this column. Okay, so you can see everything. So if you want to arrange this data in a good way, so what you can do, you can select sort story. You can select page layout, not page layout. You can select insert, and select pivot table. Okay, and click OK here. So here you can see we have like we are developing the pivot table for the better arrangement of the data. So here you can select story and drag at the column. Okay, so let's select labels and drag at row. Okay, here you can see you are seeing all the labels here. Let's drag the unique name, and let's take a unique name and drag in rows. Okay, so here you can see the unique name also. Okay, so don't take the unique name. So select sections and drag in row. So you can see all the all the labels and sections for the of all the columns here in column. Okay, so let's what we can do, let's drag this above the label. And now you can see for C1 it's 300 by 450. You can see all the corresponding labels for this size. Okay, and here you can see for C2 it's 400, 400 diameter is there for column, and you can see all the corresponding labels for this column size. Okay, so you can see it's C23 is C24. So let's go to the model. It's, you can see it's C23 is C24, and you can see these are the circular column. Okay, and all the other column size is 300 by 450. Okay, you can see here. So that's how you can represent your data in a different way. So let's go to the it's a PMM ratio or rebar percentage. Let's click here and drag at the value, and click at the arrow down button, and select value field setting, and select the max, and click OK. So here we will see the maximum data. Okay, maximum data at the each story and at the each floor. You can see here. So what you can do, you can let's drag this. So click on the new sheet. Okay, add a new sheet, and what you can do, you can select the data from like this. Okay, you can select the data, you can copy the data in different uh, in different sheet. Okay, sheet 3. Let's name it as a, let's name this sheet as a column reinforcement. So it's a column percentage. You can see it's a percentage. Let's, okay, it's a column percentage. Okay, so column reinforcement percentage. Let's name it as okay. So what you can do, it is in, it is not in the percentage. You can see. So all the data is not in the percentage. So what you can do, you can simply select the data. You can, you can delete the grand total from here. So what you can do, you can select the data, okay, and click on percentage here. Okay, you can see now every results you can see in the percentage, and click on this increase decimal. Okay, so up to 2 decimal you can see the results here. So what you can do, you can drag the data. Okay, you can drag the data. So let's drag the data in this. uh, okay, so what you can do, you can drag this from here. Okay, so the plinth, then second, then plinth, first floor, second floor, third floor, Mumty. So okay, so terrace will be at this level. Okay, so what you can do, you can again select the data, copy the data, and paste here. Okay, and you can delete the unnecessary data from your sheet column reinforcement percentage, and you can select the data, and you can click on the percentage, and up to 2 decimal you can see the results here. So that's how you can see the results in a better way. Okay, so there are many methods to see the results. You can see the results like this also. Okay, I think there is no data here. Okay, delete this one. So you can see C23 and C24 are these columns are terminating at first floor. Okay, so so you can see that C23 and C24, these columns are terminating at one first floor. Okay, so what you can do, you can go to the this, okay, and plinth. You can see the columns are at plinth level, and at the first floor there are C23 and C24, and now at second floor there is no C23 and C4. So the Excel will give you the correct results. Okay, you can compare the data. You can compare the all the labels from model also. Okay, and that's how you can see your, you are doing correct. You are whatever you are doing in the model, these results are correct or not, you can see like this. Okay, so okay, fine. I think that's enough. So that's how you can see the data. So I'm not giving you the training right now about the detailing. Okay, first we will do the reinforce. First we will do the foundation design, and after that I will teach you how you can detail the columns and how you can detail the beam reinforcement. Okay, and you will have a better understanding about the detailing after my the column detailing, beam detailing class. Okay, so what we will do today, we will design isolated foundation. So today we will design the isolated foundation. Okay, so here you can see in the in the diagram, it's a pile foundation. Okay, so forget about this pile foundation. So before the pile foundation, we will design the isolated foundation, and after that what we will do, we will also design the pile foundation, and we will compare which one is cost effective. Okay, so which one is the cost effective, and what are the, and when we will design the pile foundation, and when we will design the isolated foundation, and when we will design the raw foundation. Okay, you will have the better idea about that. So first we will design the isolated foundation using the Excel. Okay, using the Excel. I think I have already shared you this Excel. If you don't have access to this Excel, you can, you can write yes in the chat box. I will give you the link for this Excel. Okay, don't worry about that. So let's start. Okay, so this building is situated in Delhi. Okay, so here you can see, the bearing capacity. Okay, the net bearing capacity is 23.5 ton per square meter. Okay, so you can see it's 235 ton per square meter soil bearing capacity in Delhi. Okay, and these are the foundation nodes. Here you can see all dimensions are in mm. Okay, so concrete grade we are using it for like it's let's use M25 here. Okay, not M30. Okay, and I think it's everything is perfect. Okay, so the minimum yield strength is 500. No, not 500. Let's take it 415. Okay, let's take it 500. Okay, fine. It's okay. Uh, so here you can see, do not provide more than 50% of lapping. Okay, it's not that much of, it won't affect much. Okay, so here you can see these are the lap length, development length for the different diameter of the reinforcement. Okay, and it's for different grade also, concrete grade. Okay, so this is the formula to calculate the development length or lap length. Okay, and you can see this is a covers, it's 20, it's 20, 25, 40, or 50, and it's a water cement ratio is 0.45. Okay, and these are the indication. So distribution steel shall be 8y. Okay, it's okay, fine, it's okay. I think so. These are the nodes for the foundation, and I think this is only this node. The foundation is designed consider 23.5 ton per square meter net bearing capacity is important, and this is also important. Like it's I think it's M25. So what is the grade of the concrete in the foundation you are using, like M25 or like Fe5? This is also important. Like what a designated steel reinforcement diameter or minimum yield strength of the steel you are taking. Like it's, let's take it 500. Okay, so so what we will do, we will go to the E tab, and we will go to the plan, we will go to the base and apply. Okay, and please make sure that your model is run and it's completely run. Okay, it's you can see, if I will click on the run, you can see there is no load cases set to run here, and click OK. And let's remove the dimension line from here. And if you want, like if you want to remove the dimension line, you can go to the set display option, and you can click dimension line, and I think let's go to here, like taskbar setting, and hide. So if you will hide the taskbar, you can see the whole window. Okay, so you can click on apply for that. Okay, so let's click on apply. I think I have to do it again. Apply. Okay, so now you can see there is only, we are seeing only joints here. So let's go to the display support spring reaction, and click on the click on the combination, and take, I think you have to take dead load plus live load, and apply it. Okay, it's a tabulated. Okay, not arrow. Okay, so I think you can see all the reactions. You can, let's go to the 3D. You can see all the reaction at the bottom. Okay, so these are the all the axial reactions in the column at the base. Okay, so these are the axial reactions we will take to design the foundation. So let's go to this. Let's go to I think it is, what is the name? So it's a display support spring reactions. Click OK, and let's click arrow here and apply. Okay, so you can see these are the axial reactions at the base. Okay, so let's go to tabulate. Let's click on tabulated. Yeah, it should be FZ and apply and OK. And go to the plan, go to base, apply, OK. And let's go. Let's zoom in, OK, for better. Uh, so it will be better to see the results. Or what you can do, you can just go to the option, uh, graphic preference. You can reduce the text size and OK. I think now it's perfect. Okay, now it's perfect. So what you have to do, you have to take the screenshot. Okay, so let's go to, I think this. Let's talk the. Okay, so it's a paint. Click on new and let's take the screenshot like this. Okay, and click save. Save as. Save as in. So let's make a new folder. Folder save. Okay, and click OK, and let's take a, let's make a new folder again. Then click foundation layout. Okay, and click OK, and click foundation layout. Okay, save and close this window and go to course Anupama and save foundation layout, and open this file in paint. Let's open this file in paint. Okay, so now you can see this file. So here what you have to do, you have to make the grouping, you have to do the grouping. Okay, so I will tell you, I will teach you how you can do the grouping. Okay, so you can see there are a lot of differences in the results. Okay, you can see that's I think it's a base support reaction is 789 789. So we can take this in a same group. It's 403, it's 579, it's 578, 439. 439 is there. So there are a lot of differences in the base reaction. So what you can do, you can make groups. Suppose let's make up to 500. So it will be in the first group. Okay, so Control Z. So here you can make groups. Okay, so for let's make first group. Okay, we have to reduce the size of the tags. Okay, I think it's not responding. I don't know why. Okay, so let's click on A and click here, and I think let's take it 12, 14. Okay, and click again. It's 14, not bold. Okay, so first group is up to 500 kilonewton. Okay, and second group is up to 600 kilonewton, and let's color it. It will be red. Okay, and third group will be up to 700 kilonewton. Okay, it will be green. Okay, and up to 4 it will be, I think, up to 600, up to 700, up to 800 kilonewton, and it will be yellow. Okay, and fifth group in fifth group will be so greater than 800. Okay, so greater than 800 kilonewton, it will be, I think, blue. So we have made 5 group here, you can see. So up to 500. So this is the first group. So what we will do, we will let's okay, draw a rectangular. So let's take black for the first group. So up to 500. So this one is in okay, in this group. This one is in this group, okay, and I think this one is also in this group. This one is also in this group, okay, and this one, not this one, okay, not this one, not this one, not this one, and okay, this one, no, not this also, okay. So I think these four foundation is in this first group, and let's let's select the red color and up to 600. Okay, up to 600. I can see this all this group. This is in the group. Okay, and yeah, I think that's it. Up to 700. So there is no, okay. There is, I think this is okay. This one is up to 700. So let's select green color, and okay, so it's in the up to 700 group, third group. Okay, it is also in the up to 700 group. Okay, and next group will be 801. So select the yellow color, and it is in the up to 800. Okay, it is in the up to 800. It is also in 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 up to 800. Okay. And now you can see this one, this. Okay, so it is, so let's select the blue color, and it's in greater than 800 group. It is in greater than 800 group. Okay, so I think the one, two, three, four, five, six foundation, there are very lot, there are, much difference in the base reaction, you can see. So we will assign different group for these foundation. Okay, so let's make another group. Okay, so it's the sixth one. In the sixth group, it's up to 400. Okay, 400 kilonewton. And let's select the color of this is, I think, let's take it orange. Okay, let's take it orange. And seventh group is up to 100. Okay, let's take this group color is, let's take the purple. Okay, so now we have seven group here. So this is how we can, if you will make the group like this, you like you will have a better understanding of the design of the foundation, and you can you know you can do the cost effective design. Okay, so suppose you are selecting the same sizes for the all the foundation, so it won't be cost effective. Okay, rather rather do the grouping. Okay, and assign the different size for the each foundation. Okay, and that will be better for the client, and it will be a cost effective, and you can save a lot of rupees of client, and for your company. So here let's select the rectangular, and let's select the orange color. Okay, and I think this is in the up to 400 group. This is in the up to 400 group. This is in the up to 400 group. Okay, this is up to in the 400 group, and this is in the seventh group. Okay, so let's select the purple color, and I think this is in the seventh group, and this is in the seventh group. So that's how you can differentiate. That's how you can do the grouping, and it will be easy to design the foundation. Okay, and uh, now I will teach you how you can select the appropriate size and depth for the foundation. So I think you have the access to this foundation design Excel. Okay, if you don't have to the access to this file, click select yes in the right box. Okay, write yes in the right box. Write yes in the chat box actually. What is saying? Deflection check. Like everything we will do in the safe, don't worry. We are just preparing the layout for the for the for the ease of the doing the design of the reinforcement. Okay, we are not designing it right now. We are just preparing it for the design. Okay, we are easing our method. Okay, if you will, directly import the load or load combination, load cases to the safe, and you will do the same in the safe, it will take lot of time to do that. So we are just, like we are just we are, doing like we are preparing layout first, and then we will design. So it will give our, on the, I think we have to do very less iteration. In just in 2 to 3 iteration, we will get the perfect result. Okay. So here, let's delete this actual load, and let's delete the, again delete the impose load also. Okay. So okay, fine. So materials, so FCU is M25 we are taking, FY is 500 we are taking. Okay. Aggregate cover is 20 mm. No, it's aggregate size is 20 mm. Factor of safety is 1.5 and 1.15, I think. Okay, so let's go to here and go to design, concrete view. You can see for the steel it is 1.15, and for concrete it's 1.5. Okay, so it's 1.15 here. The cover is 50 for foundation. Okay, and it's a concrete density. Concrete density is 24, 25. Let's take it 25. Okay, soil. Okay, soil density is 18. And bearing pressure, so bearing pressure, let's go to the our drawing here, and you can see the bearing pressure is 235. Okay, 235 kilonewton per meter square. Okay, and I think everything is perfect. It's M25 FE 500. Okay, I think it is, yeah. Stone aggregate is 20 mm. Everything is perfect here. You can see. What he's saying, reflection. Ankit, what are you saying actually? I can't see your. Sir, there is one doubt. Ankit, you can unmute yourself. You can ask the question. I'm not able to see it. I don't know why. Okay, why we only selected like one full reflection check. Okay. So we are not doing any checks here. We are just preparing the foundation layout. Okay. We are easing our method actually to do the foundation design. So we, like, I have not taken moment here. Okay, moment here. So we will check for the moment in safe only. Okay, we are only like selecting dead load plus live load here. Okay, because we want to ease the method to design the foundation. Okay, so let's take the dimension from the base. Okay, you can see it's LBH depth, or it's a eccentricity. The eccentricity is 0 in X and Y direction. Here you can see the column size. So we have to select the column size here. So I think the column size is it's 300 by 450. Okay, so let's take it 300 by 450 and 300. Okay, so this is the column size, and okay, so we will do for the group 1. Okay, first the group 1 is 500. Okay, so the black one is a group 1. So we will see the maximum base reactions for the group 1. Okay, I think it is 439, 439, 438, and 403. So let's take it 450. Okay, let's take it 450 here. Okay, so here you can see the punching. Okay, you can see the ground bearing pressure check. Okay, you can see the bending is here in X and Y direction. You can see the shear we are getting in X and Y direction. You can see the punching we are getting in the X and Y direction. So here what we will do, mm, we will just select the dimension, different, I think foundation width. Okay, So let's select 2500 and 2500. Okay. So here you can see the in punching it's perfect. It's punching it is okay. So what you can do, you can reduce it. You can reduce it also. 2000 and 2000. Okay. I think it's 229. So what you can do, you can reduce the depth also here. So let's go to. So you can see in punching it's 29%. So if we will reduce the depth, the punching will increase. Here you can see. Let's take it 300. So you can see the punching has increased, bending also increased, and ground bearing pressure also increased. So I will recommend you to take 400. Okay, everything is perfect. You can see the bending. So we have to reduce the bending also. Please try to maintain everything is around 50 to 60%. Okay, let's 60%. If you maintain it from 50 to 60%, your reinforcement result will be around less than 1%. So you can do the cost effective design for your client or for your company also. Okay. So let's increase it. It's 2100, 2100. Okay. Okay. Bending is increasing. You can see that's 220, 2200, 2200. Okay. It's 76% here. Okay. 2500, 2500. Okay, it's 82% here. You can see in X direction. Okay, so like I want to reduce the bending in X direction. So for that, what you will do, but what I will do, okay, it's a height. Okay, so not like this. So here you can see H by B ratio. You have to increase you have to take the length and width as per the H by B ratio. Okay, so let's click here. Okay, so H by B. Okay, so it's 450 divided by 300. It's 1.5. Okay, so if you will take B, suppose we are taking B 200, 2000 mm into 1.5. Okay, you have to take 300 here. This. Okay, let's take it 200. Okay, so you can see the punching. You are getting punching. It's 100%. So you have to reduce it also. Okay, so what we will do, we will take it. I think. Uh, let's take it from it's 200, 2500, 37. Okay. So let's take it 2000, 3000. Let's take it 500, 450. Let's take. Okay, so you can see every result is in between 50 to 70%. Okay, I think we can take 300, 200. Okay, so let's take this one. So 300, 200. So for the first group, okay, we can take this data length, width, and height. Length, width, and depth. Okay. Yeah, sure. So you can write it like this, and for group one, it is. Okay, so now we will now we will do for second group. Okay, so this for the second group you can see it's 579, 578. So you can take 580. Okay, let's take it 580. So here you can see it is giving you the suggestion for the base size. Okay, you can see here. So rather you can go for the square footing or you can go for the rectangular footing also. Okay, so let's select this 1255 and 2000. No, it's not appropriate actually. As you can see, it's 100% here. Why it is showing like this? Okay, uh, I think we have to take our own. It's 1.5. Let's take it 2000, 3000. You can see it's 88%. So what you can do, you can increase it to 2200. Let's take it 2.2 into 1.5. It's 3.3. You can see its bending is 93%. Okay, so length is more. That's why. You know it is correct. It's 2800. Okay, let's take it 2600. It's 2500. Okay, so I think everything is perfect. Okay, it's why it is less. It's 2500 2000. हम्म।
सर इसमें मोमेंट भी तो कंसिडर करना होगा ना?
हाँ हाँ, मोमेंट कंसिडर करना होगा। मोमेंट हम लेंगे उसमें हम सेफ में देखेंगे मोमेंट का।
अच्छा।
So moment as compared to the axial load, moment is very less. Okay, so just you have to do just some changes in the foundation, and it will be final for the doing the detailing. You just have to do some changes, like little bit changes you have to do. It's okay. So I think let's take it 450. Okay, 450. Okay, it is showing very less results. Let's take it 400, 350, 350, it's 200. Okay, it's showing the results perfect, but it's 82, right? Let's take it to 200. Okay, it's perfect. Now it's perfect. Okay. Okay, so so let's take 2.2 and 2. Okay. So length is okay. Now I think we are doing perfect. Okay. So it's okay. So for group one, we have done it. For group two, let's do it. I think it's group two, right? Red one. Select red one and click OK. And I think let's take it 2500. I think it is 480. Okay, let's take it 600. Um, you can see bending. Okay, we are get bending, so let's increase this one. Okay, now it's 94, 92%. So what you can do, you can increase it this one also, but not this much. So okay, let's take it 500. Okay, and 2800. You can take it. Okay, I think it's 2800. I think its suggestion is wrong. I think it's not good suggestions. Okay, so every result is in it's in between 50 to 70%. So we can take this 28 and 25 and 500. Okay, so let's write. I'm just writing it. I'm doing it very fast now. Okay. Uh, okay, so now for the third group we can see it's only 670 and 615. Okay, there are only two foundation. So what you can do, let's take it 650. Okay, let's take it 650, and okay, let's take it. It's 3200 and 2800, and let's take it 600. Not 600. Let's take it 500. Okay. So I think it is more. Fy is more. So what you can increase it? Mhm. Okay, it's 62. Let's increase it again. Okay, and I think it's 99%. Okay, so what you can do? Let's take it 300, 349. Okay, let's take it 600 and 3200. Okay, now you can see every result is in between 50%. So I think okay, let's take it 3 1. It's 2800. Okay, and let's take it 3000. I think it's also okay. Let's take it 500. Okay, so now you can see every result is in between 50 to 70%. So we can take this one 300, 300028 and 500. Okay, let's take it 5550. Okay, now it's perfect. Okay, so it's for third group we will do for fourth group actually. So for fourth group it is 7. So let's take it 800. Okay, I think it should be it will be 800. So let's take it 800, 800 only. Okay, and let's increase this 3200, 3000. Okay, and let's take it 600. So every result is in between 50 to 70%. So we can take this data. I think it is in yellow color. Okay, let's take it yellow and 3. Okay, and now I think it is fifth one. So blue one, you can see it's 1110. Let's take it 1150. Okay, you can see the bending. We are getting bending. Okay, more bending is there. So what you can do, you can let's increase this. Okay, and okay, fine. I think it's okay. We can increase 3500, and let's take it 3200. Okay, so every result is in between 50 to 70%. Okay, so you can also increase it 3600. Okay, and 3250. No. Okay, it's perfect. I think. Okay, let's do it again. Okay, 3300, 3800. Fy. Okay, Fy bending is more. So what you can reduce it. No, you have to increase it. I think we are getting the same result. Why? Okay, so now you can see every result is in between 50 to 70%. Okay, so we can take this data 3800. So let's click blue and 3800, 3500, 750. Okay. Okay, now it's done, right? It's for now for it's sixth or seventh one. So for sixth one, it's only 400. Okay, so what you can do, you can take it's this one, two by two. It's 400, right? So let's make 400. Okay. So let's take it 350. Okay, let's increase. If it's in X direction, okay, it's X direction. So, okay, let's reduce it this one. Okay, so now every result is in between 50 to 60%. Okay, so now we can proceed. So it's for okay. So I think it is for this one. Let's take it 2000 1800 and it's 400. Okay, and you can see this is very less. I think it's up to 100. So now whenever you're designing foundation, okay, please make sure that suppose this is our column and this is our foundation. Okay, this is section. So whatever depth you are taking, at least take from face of the column. So it should be more than that. Okay. Suppose this is D. So the end of the foundation and face of the column dimension should be more than D. Okay. Every time, please make sure about that. So let's take it. I think we can take it 1000 by 1000. Okay. So I think it is only 100. Okay. So we can take it 1000 by 1000. And minimum depth, this D minimum depth is 200. So don't take it less than 200 every time. Minimum depth is 200 as per the IS 456. So let's take it 200. Okay. So you can see every result is quite good. Let's take it. I think 800 by no, it's okay. So you can see every result is in between 50 to I think 50 to 70%. Okay, and yeah, we can proceed with that. So select purple and 1000 and 100. No, not 100. It's 200. I think. Okay, so you can see we have designed everything as per the dead load plus live load only, not for the moment we have designed it. So for the moment we will design it in safe. Okay, I think there won't be much changes. Okay, there won't be much changes in this sizes. Okay, there will be only at some at I think at some groups it will I think safe want I think safe will give us the results that you should increase the foundation here. You have increased the foundation depth, or I think maybe some. I think you have to check in the punching also in the safe. Okay, so let's proceed with that. So let's open the ETA model. Okay, so let's go to 3D, and I think you have to click on the show undeformed shape. Okay, and I think everything is perfect. So before exporting the loads from the ETA model, please make sure your model is unlocked and it's run. It's totally run. You can see there are no load cases set to run. Okay, so every load case or load combination should be run. Okay, let's I think go to the define load combination here. I think there are different. Okay, so you can see this is unnecessary load combination in this. This what you can delete this, and okay, and you have to check everything. Okay, everything you have to check. So okay, everything is perfect, and click OK, 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 and run. Okay, there is no load case set to run. So what you can do, you can if you want to export the file, so first you have to go to the file, then you have to go to export, then you have to go to add story as safe. Okay, so please select this export floor loads and loads from above. Okay, this one, because what we are doing, we are okay. 1 minute. Okay, so we will import this one, right? So here, okay, so what we are doing, so suppose this is our plinth level, this is first floor, okay, this is second floor, this is third floor, fourth floor, fifth floor, sixth floor, okay, and this is our base point. So this is our base point. So what we are doing here, you can see we are exporting floor loads and loads from above, and we are selecting base here. So what it will do, so it will take all the load from the base point. Okay, so every load from above from the base point it will take. Okay, so what you can do, you can design the foundation at the base plate, at the base point. Okay, so there will be a foundation, and we have exporting all the load above from the base point, you can see here. Okay, so that's why we are doing it. You can select all the load cases, you can select all, and okay, here you can see 10 out of 10 load cases selected. Please select load combination, select all, and you can see it's 46 out of 46 load combination selected, and click OK. So go to the safe. Okay, here make create a new folder, name foundation. Okay, and you can see here ETABS. You can name it as a ETABS export loads. Okay, and click save. So now you can see all the load combination is exporting from the safe model, now from the ETAB model. Okay, and so there is no need to now there is no need of ETAB model. Okay, so what you can do, we can minimize it. Okay, there is need of we need this image. Okay, for the preparing of the, so this we have already prepared the foundation layout. Okay, now what we will do, we will model the foundation as per our this foundation layout in safe. Okay, so let's do it. Let's design the foundation. Okay, so first you have to open the safe. Please make sure you are doing design in safe 2016. Okay, so if you are doing design on safe 2016, it is most appropriate software. Please don't do in safe 20 or safe 21. Okay, because you can export the model safe 16 in the newer version, but if you are doing design in the newer version, you can't export the model in older version. Okay, so always do the modeling in older version, not in the new version. Okay, so if you want to if you want to import the load from the ETAB, you have to go to the file, import safe.f2k file, and go to the folder, go to your saved folder, and let's go to uh, safe. Foundation safe. Okay, this is the export load from ETABS, and click open. Okay, and go to set display option, select point invisible, and okay. So now you can see all the point. Okay, you can see all the points where we have exported all the loads. So if you want to see the loads, what you can do, you can simply go to show loads. Okay, and here you can select load, dead load above. Okay, and click OK. So in the red points you can see the loads here. Okay, so these are the all the loads. So we have imported axial loads, we have imported uh, shear reactions, we have imported base reactions from earthquake and wind. Okay, we have imported all the moments also. So let's have a look at that. Okay, if you will select the joint and click right click, you can and go to the loads. Here you can see we have exported all the dead above, live above, earthquake X in direction above, earthquake in Y direction, earthquake in Z direction. Okay, wind in X direction, wind in Y direction. Okay, you can see we have imported all the moment also, moment in X direction because of the wind. Okay, we have imported all the modal cases also. You can see all the modal cases we imported. Okay, there are, I think we have considered almost 50 modes in this. So we have imported all the modes. Okay, and click OK. So if you go to the define and load pattern, you can see all the load pattern is here. You can see it's a self-fade, finish, service, sunken, wall, live less than 3, live greater than 3, EQX, EQY, EQZ, wind load in X direction, wind load in Y direction. Okay, you can see every modal cases here. You can see all the modal 50 cases we have also imported. So that's how you can see all the loads. Okay, so if you want to do the modeling, what you can do, you can simply like this. You can divide the windows, divide the window, your window. Okay, and now you can see like this. Okay, I think it will be better to understand what we want to model and and what we will model actually. Okay, so here you can see these are the 2 points. So first we will start from this. Okay, so first we will start from the group one. Okay, the group one is it's 2.2. Okay, so let's select this here. Uh, Quick draw area around points. Okay, so here you can see no. Okay, fine. So what we can do, we will assign material properties. Okay, so let me open my presentation. So everything we will do step by step. Okay, there is no need to panic. Okay, there is no need to like take your time, be patient. Okay, like patience is everything. Okay, once you have a patience, you will learn everything. Like be patient every time. Okay, so we have imported here load cases, load combination. Okay, so we will define the material properties first for concrete and steel. So for that, what you can do, you have to go to define material. Okay, here you can see there are some different material properties is already. So what we can do, we can add a new material. Okay, we can add a new material like this. Okay, you can see this is a concrete is there, rebar is there. Okay, so it should be M25. Okay, so unit weight should be, I think it's 25 or 24. You can take anything. And modulus velocity is 5,000 root FCK. So it will be, I think, 5,000. It's 2500. Okay, or you can like 5,000 under root FCK. Okay, it's 25 to the power of. No, it's not correct actually. So we can do like this also. So it's 25 under root into 5,000. Okay, it will be 25,000. Okay. I think Poisson ratio for the concrete is same. It's also okay. Shear modulus is okay, and it should be M25 here. Okay, and click OK. Now we have successfully assigned material property for concrete. Now we will assign for uh, steel. Okay, for steel grade we will assign. So for that we will go to add new material. Okay, here you have to choose rebar, and it should be Fe 500. Okay, so you want these minimum yield stress Fy, minimum tensile stress Fu, modulus of elasticity, and unit per unit weight. Okay, this data you want. So what you can do, you can go to the ETAB for that. You can go to define material properties, and FE5 HYSD 500. You can show material data. You can take data from here. You can see the material. So unit weight per volume, it is 76.97. So I think it's correct. Modulus velocity, it is 2000, 2 into 10 to the power MPa. Okay, so 2 into 10 to the power 5. Okay, it's, I think it's 200,000. Okay, so it will be, I think, 2 lakh, right? So let's take it that one. Okay, and you can see minimum yield stress and minimum tensile stress. So you can go to show modify show material property design. So here you can see it's Fy. Okay, so minimum yield stress is Fy. You can take it 500. No, 1 minute, 1 minute. Fy, it is, you can take it 500. Okay, and it's Fu, minimum tensile stress. Okay, Fu you can take 545. Okay, it's in MPa, it's in Newton. It's same, I think it's same. Arnav, these results are same, right? Fy or Fu, right? Hello, Arnav. Arnav, can you hear me? Okay, Arnav is not there. Okay, fine, it's okay. So minimum yield stress, you can see it's Fy or Fu. Okay, I think it's correct. It's correct. Okay, it is perfectly correct. And we can click OK, and click OK. And here we have defined the material properties. Now we will define the slab properties, and we will assign the slab properties. To define the slab properties, what you can do, you can go to define slab properties. Here you have to add new properties. So what we will do, we will define the properties using depth only. Okay, so you can see we have like using different depth: 400, 500, 400 here, 500, 750. Okay, okay. So what we will do, we will uh, add we will go to the add a copy of property, and here you can select the material properties M25, and you can take slab. Let's assign for 200. Okay, 200 is there, and click OK. You can delete this one. Now add a copy of property, slab 400. Okay, let's take it 400. Click OK. Add copy of property. I think it's 400, 400. Okay, it's 500, 750 is there. So you can 500, and let's take it 500, and click OK. Add copy of property. Okay, it's you can say it's 550, then 750. So let's take it 550 is here, and click OK, and add a copy of property. Let's take it 750 here, and let's take it 750 here, and click OK, and click OK. Okay, so I think 400 is there. Okay, 5, it's okay. 200 is okay. Okay, I think okay, there is 600 also. So what we will do, we will add a copy of property, and we will add a 600, and click OK, and click OK. We have successfully assigned all the depth for the foundation. Now we will model it. Okay, so you can see in we will assign, we have defined the slab properties. Now we will draw the slabs. Okay, So to that you have to go to the quick draw. Okay, so you have to select the slab first. Okay, here it will be like rectangular slab, and you have to select the property. Okay, so let's do it for group 1. So what you can do, you can divide the windows. Okay, and now let's select this. Okay, and here you can see, you can for group 1 it is 400. So let's select 400, and it is 2.2, and it's 2. Okay, so I think it is around, okay, it's here at this location. I think it is around 1 minute. So orientation, you can see it's vertical. Okay, orientation is vertical. So orientation should be vertical. Okay, so x direction it's 2.2. No, it should be 2 here and 2.2 here. Okay, now we can place it like this. Okay, now we are doing perfect. It's here, here, and here. You can see at 55, 56, okay, and 72, 73. We have assigned it successfully. Now for second group, we will do it. Okay, so for second group, it is 2.8. It's 2.5 and 2.8, and it is 500 here. Okay, now do it like this. Okay, and it's done. It's done for 58 and 70. Now third one, let's take it 2.8 and 3. Okay, 3 and 2.8, and it should be 550. Okay, and I think there is only at the two place. Okay, it's 61 or 75. At 61 and 75. Okay, now it's done. Now we will do it for fourth group. Okay, you can see there are a lot of foundation for fourth group. So fourth group it's 3.2 or 3. Okay, so now what you can do, you can, I think it's 600, and you can click these 2 point. Okay, and these 2 point. Okay, right, or these 2 point also. And now for the fifth group, it's 3.5. It's 3 here, 3.8 and 3.5. 3.8 and it's 3.5. Okay, and it is 750 here. It should be 750. Okay, now you have to select this and this. Okay, so at this location you can see it's 1.1 is here, or 1.0 it's 2. It's 2 is here, it's 1.8 is there. Okay, and I think it's 400, and you can select this one, this one, this one, and this one, and I think it's 1000 by 1000. Okay, and let's take it 200. And okay, so we have done successful modeling. You can see there are a lot of foundations overlapping to each other. So what you can do, you can simply merge these foundation. You can merge these foundation like this. So you can select these two foundation and go to edit and areas and merge the foundation. You can see the it's merged the foundation. Okay, you can go to edit and merge the area. Okay, now here also you can merge the area. You can select this and you can merge the area. Okay, and here also you can select this and you can merge the area. Okay, and here also you can select the area and you can merge the area. You can drag the area, okay, and you can merge the area. So there is no need to take this, like it's a very less, okay, it's very less less space in between these two foundations. So what you can do, you can merge this, okay. So if you want to merge it, if you want to drag it, you can go to reshape and select it, and you can reshape it also, okay, like this. And you can reshape these also. And what you can do, you can merge it, okay. You can drag it, edit. 1 minute. Go to edit area and merge the area, okay. So here also you can merge the area, okay. So I think it's very less space. So what you can do, you can drag this and you can merge the area. I think it's perfect, okay. It's looking perfect. And yeah, you can do any changes if you want. Okay, so now we will learn how to assign the columns, okay. So we have to draw the column and wall. So there is no wall in the model, so we have to draw the column first, okay. So let's go to our framing. Not this one, this one, okay. So we have to draw these columns on the foundation. So what we will do, we will just so we will go to the our ETAB model. So we'll go to the ETAB model and we will check. So what is the, okay, so you can see it's a height of the first floor is almost 3.15, okay. So we will take height of the column is 3.15 for the foundation. And here we will take I think, okay. So here what we are doing, we are not taking weight of the column. uh, we are not applying weight of the column on the foundation, okay. We are just adding the columns on our foundation to see the results only, okay. So we can see the results in a better way, so that's why we are adding column. The weight of the column is already on the foundation, as I have told you that above the base point we have taken all the loads, okay. So here what we will do, we will go to the define, will material, and we will go to M25, add a copy of material, and we will take 0 here, okay, 0. So we are not taking any weight here, okay. So let's take it M0 and okay, and click OK, okay. So now we will go to the define and we will add a column property, okay. So we will add a so let's go to the add a copy of property, and here you can see the two columns are there is 300 by 450, and orientation is vertical, okay. So you can see here, let's take it M0 here. We are not taking weight of the column. So see, I think it is 300, it's 300 by 450, okay. So it's 300 by 450. Okay, so let's take it. I think it is 450. No, it's 300, and it's 450. Okay, and okay, and we are also adding so let's add a copy of property, okay. And here it should be C 400, and we will take a circular, and let's take it 400 and click OK and OK. Okay, so here you can see these are the circular columns. So we will add a circular column first. So let's add it. So if you want to draw the column, you can go to the draw column. Okay. So here let's select it for let's select the C400 and property above C400. Okay. So at the property below, let's take it none. Height below, let's take it 0. So in height above, let's take it 3.15. Okay. And click OK. And here also click OK. So we have successfully added circular column. Now let's take it 300 by 450 and let's add the column. Okay. So let's go to 3D. Okay, you can see we have successfully assigned the column. Okay, and we can see our results now. Okay, so let's go to okay. So let's open my presentation. Okay, 1 minute. Give me a sec. So now we have to assign the subgrade modulus. Okay, to assign the subgrade modulus, what we can do, you have to select every slab here. Okay, and you have to define the soil subgrade properties. You have to modify it. Okay, here let's write SBC. I think it's 235. So you can see it's 235. Okay, so it's 23.5 ton per square meter. Okay, and here you have to write the subgrade modulus. Okay, so if you want to uh, calculate the subgrade modulus, this is the formula. Okay, 1 minute. Let me give you the brief about the subgrade modulus. Okay, so if you want to calculate the subgrade modulus, this is the formula. So I think SBC divided by deflection of the permissible deflection of the foundation. Like for the isolated foundation it is 50 mm, and for RAF it is 25. Okay, and I think this permissible settlement and permissible deflection is written also in the soil subgrade soil report. It's also written in the soil report. So if you want to calculate the subgrade modulus, okay, subgrade modulus, so the formula is SBC divided by deflection, permissible deflection. Okay, so in our case the SBC is 235 kilonewton per meter square divided by 0.050. Okay, this is isolated foundation. So our subgrade modulus will be 235 divided by 0.050. Okay, so your subgrade modulus is 4700 kilonewton per meter cube. Okay, it's in meter. It's in mm. Okay, now it's in meter. Okay, you have to divide it by 1,000. So here you can see you have to put the value for kilonewton per meter cube. Kilonewton per meter cube is there. Okay, so you have to put 4700 in this box. Okay, it should be compression only. And here you can see you have to put 4700 here, and it should be compression only, and click OK. And click OK. And So select the all the slabs. Okay, go to the assign. Uh, Go to support data soil properties. Select SBC 23.5 ton per meter square. Click OK. You can see you have successfully assigned SBC for 23.5 ton per meter square. Okay, so we have assigned successfully SBC also, and let's go to our presentation again. So now we will update the design code. So if you want to update design code, you have to go to the uh, display, not display. Go to the design preference. Okay, here should be IS 456 2000. Okay, and it should be 1.15 for gamma concrete is 1.5. Minimum cover should be 50 for foundation. Okay, and preferred bar size, let's take it 16. Minimum bar size you have to take. Let's take it 16, or you can take it 12 also. And click OK. It should be two-way. Okay, every time it should be two-way. Okay, and click OK. For beam, it should be 50-50 also. Okay, for the foundation beam, it should be 50-50. Okay, you can see the strap. If you want to assign the strap beam in between beam to beam, so it should be 50, and click OK. So I think it's perfect. Okay, it's looking perfect. And so okay, we have updated the design code. Now you have to draw the design strip. So what we will do, we will cover this in the next part. The strip we will cover in the next part. So we have to assign the degree of freedom. Okay, so it's a 2D plate. So we have to assign the degree of freedom. We will assign it 2D plate. Okay, so to assign the 2D plate, you go to the assign, not assign. You have to go to the run advanced modeling option, and you have to click it 2D plate. So here you can see the active degree of freedom is in the Z direction only. Okay, so what we are doing, we are restraining the deflection in X and Y direction, and click OK. So now we have to delete the beam at the joints of the wall. So you can see there is no wall in the model. Okay, so there is no need to delete the beams because there is no beam, okay, in the model. So now what we will do, we will run the model, and let's run the model. So you can go to the FD and you can click it. You can name it as a G+3 uh, FD foundation and click save. So for isolated foundation, the permissible deflection is 50 mm. So if you want to check the deflection in dead load plus live load, you have to go to show deform shape. Okay, here you have to select the load combination, that is dead load plus live load, and click OK. Click apply. So you can see you are getting maximum. I think you are getting maximum deflection is 24 mm. Okay, you can see here. Let's go to 3D. Okay, so negative means your deflection is in the downward direction. Okay, positive mean your deflection is in the upward direction. So there is no positive deflection. So that's, I think, quite good. If you are getting positive deflection, that means you are getting deflection in the upward direction. That is, I think, uplift you are getting on the foundation. That is not desirable at all. Okay, so so you can see you are getting 21 deflection here in negative direction. Okay, here you can see it's 23 here. Okay, it's 23 here. So that is under permissible limit. Okay, so the our permissible limit is, I think, 50 mm. We have taken, right. We have taken 50, right. Let's okay, let's okay, it's 0.05, right. So it's 20 mm. So what we can do, we can reduce our depth. We can reduce sizes also if you want. Okay, I think we have over designed it. we have taken maximum load. Okay, that's why we have over designed it. Okay, so I think we have taken results of 50 to 70%. So what you can do, you can take results from like 70 to 90%, 90% also. Okay, so if you want to check in the SPC, okay, here you can see we have checked for the deflection limit for dead load plus level load, and let's check it for the earthquake and wind also. So to check in the earthquake and wind, so what you can do, you can go to the show deform shape, and you can select the service load combination as a dead load plus spec X and apply. Here we are getting 18 mm. You can see at the left bottom you can see 18 mm. For the minimum also, let's check it. You can see we are getting 29 here. Okay, and let's check it for the dead load plus spec Y for maximum. Apply. We are getting 21, and for minimum we are getting 29 again. Okay, let's check it for the dead load minus spec X maximum. Apply. We are getting 18 mm. Dead load minus spec Y maximum. Apply. We are getting 21, and for the minimum also apply. We are getting 29 here. Okay, and again for wind also we have to check. So let's select the dead load plus wind load and apply. We are getting 22, and for dead load minus dead load plus wind load in y direction, apply. We are getting 22. Dead load minus wind in x direction, apply. We are getting 22. Dead load plus minus wind in y direction, we apply. We are getting 22 again. Okay, so I think everything is under permissible limit, and we can close it. And we have checked in the deflection. Okay, so if you want to check in the SBC, I think it's the soil bearing capacity. Okay, safe bearing capacity. You can check in the safe bearing capacity or in the net bearing capacity. So safe bearing capacity is equals to net. I think net bearing capacity is equals to safe bearing minus overburden pressure. So we are not taking the safe bearing capacity. We are taking net bearing capacity. Okay. So what we are doing, we are already removing the overburden pressure, and we are designing for the net bearing capacity. Okay. We are not taking here the overburden pressure. Okay. So if you want to like if you want to check for the SPC, you have to go to the reaction forces. Okay, and here you have to select the load combination. Let's check in. Let's check it in the dead load plus live load. Okay, you have to select the soil pressure and apply. So here you can see we are getting maximum. It's 114.994. Okay, and I think our permissible limit is 23.5. Okay, 23.5. So here you can see it is 114.94. So we have literally over designed it. Okay, we have taken results from 50 to 70%. You can take results from 70 to 90%. Okay, so we can reduce the sizes, we can reduce the depth, we can reduce anything we want. Okay, so let's check it for the earthquake load also. Apply. Okay, here you can see it's only 87 in maximum, and it is in, I think it is only 139 in minimum. For y direction maximum, apply. We are only getting 102 in max, and we are getting 137 in minimum. Okay, let's design it for dead load minus spec x and apply. It's 139 for minimum, and maximum it is 87 only. Okay, and let's go to the dead load minus spec y, and for max apply. It is 102, and for minimum it is, I think, only 137.245, 137.52. So here is a one concept I want to tell you about that. So in earthquake, okay, in EQX or EQY, so in spec X or spec Y, The permissible limit is depend on the soil type. Okay, so whatever soil type you are using, for suppose you are using soil type 1, soil type 2, or soil type 3. Okay, so for soil type 1 you can increase a permissible limit by 50%. That means you can multiply. So you can multiply 235, not 235. I think it's okay. It's 235. You can multiply 235 by 1.5. So it's 352 is your permissible limit. Okay. So for soil type 2 it is 25%, and for soil type 3 it's 0%. Okay. So suppose your soil type is 2, so it's 25%. So your permissible limit will be in earthquake will be 235 into 1.25. So it will be 293. Okay. So in ETAB model, you can see a defined load pattern and EQX modified. You can see the soil type is 2 here. Okay, so we can increase the soil bearing capacity by 25% for the earthquake check. Okay, so here what we have done, we have over designed it. Okay, so what you can do, you can unlock the model. Okay, and you can reduce the sizes. Okay, so let's do it right now. So we can reduce the sizes. Okay, so let's delete it. Okay, let's delete this one also. Let's delete this one also. Okay, and what we will do, we'll go to 3D. So here, what we can do, we can reduce the sizes. Okay, so let's do it right now. Mm. So if you want to reduce the sizes, what you can do, you can select the slabs here. You can see you can select the slabs and go to edit and edit areas. Okay, and expand and shrink. Okay, if you want to shrink the area, let's do it by minus 200 mm, and okay, you can see your sizes have has reduced by 200 mm. Okay, that's okay. I think you have to select everything. Okay, now let's go to edit area, and write minus 200 and apply. You can see your sizes has reduced. Okay, now what you can do, let's take it this one only, 2.2 or 4. Okay, 2.2 or 2. Let's go to edit. Okay, mm, let's take it 1.5 by 1. Oh, not 1.5. Let's take it 2 or 1.8. Okay, okay, 1 minute. What you can do, you can take it. Okay, fine. So here what we can do, we can take it like this also. Okay, let's do it like this. Let's take it uh, zero point 0.5. Let's take it 2 by 2. Okay, and assign it at every point. Mhm. and we can select this assign 400 and okay, and go select it, go to assign support data soil property and okay. Let's run it. Okay, let's check everything again. So here now your you can see the deflection is 53 now. Okay, so deflection is 53. So what we have to check the deflection. We'll go to the show deform shape. Okay, and here we will select dead load plus live load and apply. So you can see our deflection is we are getting 61 here. So you can see here we are getting 61. So in the previous model we have over designed it. We have over designed it. So what you can do, you can increase the size of these foundation only. Here you can see we are getting 44, 42 is there, okay, 35 is there, 22 is there, 35 is there, okay, 31 is there. So you can only increase these foundations depth, okay, or you can increase the width also. So here what we will do, we will increase the depth. Let's increase the depth. Define slab properties, and I think let's increase the depth, like okay, I think it is this one, right? Okay, so let's take it 600 only. Okay, it's by let's select this, go to assign slab data properties. Okay, okay, by select this, go to assign properties and clicks and okay. You can see it's 600 now. Okay, so we will select this. Okay, again we'll go to edit area, expand the area from by 200. Okay, and okay, and now we will run it again. So to check the deflection, you have to go to the deform shape. Okay, you have to click the load combination dead load plus live load again and click apply. You can see we are getting 44 now. Okay, so that's how you can you can save your structure to know, you can save your structure. Okay, you can ensure the integrity of the structures and failure. Okay, so I think we have to check it in earthquake also. Okay, apply. You can see we are getting 37 here. Okay, for maximum and minimum. So now we have to check it for SBC again. Okay, let's check it for SBC. Show reaction forces. Okay, and for soil bearing pressure, let's uh, click dead load plus live load and apply. So here you can see we are getting 208. Okay, 208. We are getting 208 in dead load plus live load. Okay, and our permissible limit is 235. Okay, so our permissible limit is 235. So now it's so now you can see it's economical. Now you can say it's economical. Okay, we are not getting it 235. At least it is showing 208. Okay, so now it's perfect. So what we have done one mistake. We have taken results from 50 to 70%. We have to take the results from I think 70 to 90%. Okay, it should be around 80%. Okay, every result it's around 80%. Okay, let's check it for the foundation. Okay, well, earthquake also maximum minimum. It's 198 and 192. It's perfect. Okay, spec Y and spec Z minimum and maximum again. Okay, it's 181, or its permissible limit is increased by 25%. So we can multiply it with 1.25, and that will be our permissible limit for the earthquake. Okay, and that's how you can ensure your safety and structural integrity for the structure. And now I think it's a final foundation for our structures. Okay, here you can see you can merge the area. Okay, you can merge this, so that will be a combined foundation, and you have to design the combined foundation for that. Okay, so that's how. So you can see it's 90%. Okay, it's for dead load plus live load. Okay, 1 minute. Apply. You can see it's 90. Okay, 1 minute. Apply. Now you can see it's 119. Okay, so what you can do, you can decrease the size again. Okay, you can decrease the size also. You can decrease the size. Okay, that will be better. Okay, so here now we have to check for the punching also. Okay, and here you can see we have to check for the punching also, and there should not be any uplift in the foundation. Okay, so in the next class we will learn about how we can draw the strip. Okay, in x and y direction, and we will check for the reinforcement. So here we will check for the punching. So let's click on the show punching shear design. Okay, here you can see the punching is quite good. It's 0.5, 0.6. Here you can see it's 1.1. Okay, so we have to increase the depth here. Okay, here you can see it's 0.45. Okay, so please make sure your punching is it's around 0.7, 0.8. If your punching is it's greater than 1, always do the punching one way shear and two way shear check in the foundation. So let's select this one. Okay, and for the one way shear check, what we will do, we will check it at the depth D, distance from the face of the column. We will check the stresses. Okay, from the face of the column. Okay, we will check the stresses at these location. Okay, and for the two way shear, what we will do, we will check at the D by 2. The punching is two way shear is none other than punching, and we will check it at the distance D by 2. Okay, I think that is quite good. So it's a better understanding how we can do the design. When we have to check for the one way shear, two way shear. Okay, and I think so. Suppose let's do it. Okay, so I think it is okay. So let's unlock the model. Okay, select this. Let's. So you can what you can do, you can increase the depth selecting. You can select the areas. You can go to assign slab properties, and you can increase the depth. I think its depth is right. It's 400. So what you can do, you can select the slabs. You can go to assign slab data properties, and you can take it 500. And okay, so you can see here it's 500. The tag, you can see that it's 500 depth. Okay, so what you can do, you can reduce the area. Okay, you can reduce the area. Go to the edit. Go to edit area. Expand and shrink. You can shrink it by 200. Okay, and let's do it again. Actually, no. Okay, I think it's quite good. I think it's 799, 789. Okay, okay, fine. It's okay. So okay, let's run it again. So let's check in the punching again. You can see now it is 0.56, 0.56. It's 500. So what you can do, you can take it 450 also. Okay, let's run it, and let's go to here, assign slab data properties. Okay, you can go to add copy of property, and it's 450. Let's take it 450, and here it should be 450. And okay, and okay, and run it again, and you can see here now it's perfect. Okay, it's around zero point 0.7, zero point 0.8. Okay, it will be better. Okay, so I think everything is quite good. So here it's zero point 0.5. So what you can do, you can decrease the depth by 50 mm. Okay, here also you can decrease the depth by 50 mm for the cost effectiveness. Okay, here also you can decrease the depth of 50 mm, 50 mm. Okay, if it is around like 70% or it's around 0.65, so you can also decrease the depth of 50 mm. So I think it is the best result we are getting, 0.7. Okay, if your result is from 70 to 90%, it is perfect. Okay, rather what you can do, you can decrease the depth or decrease the size, whatever you want. Okay, whatever client want, whatever is the corresponding, and whatever is the whatever is the situation. Suppose your plumbing, suppose your plumbing pipe is going from here. Okay, so what you can do, you can increase the width from these locations, you can reduce the width from here. Okay, so that's also you can do. Suppose your electric wire is going from this location, so okay, what you can do, you can decrease the size from here, increase the size in lengthwise. So whatever you want, you can do, and you can check whether your results are passing or not. Okay, so you can also, if you are changing size, you have to check it again for soil pressure. Okay, let's apply it. You can see it's 161 here. You can see we have reduced the size. Now the bearing capacity is 161. So I think it's perfect. So this is the best way to do that. Okay, so here in the results, here in the results, what you can do, uh, so the ground bearing pressure and punching, you have to check it for that. Okay, you have to check it for bending also, because of the bending, because of the bending is due to the moment, and because of the bending you will get the more reinforcement. Okay, so please make sure it should not be about like 90% or 100%. It is in between around 70 to 80% or 90%. Okay, so let's do it for one foundation again. Okay, let's check the let's compare the data. Okay, so what results we are getting. Okay, let's compare the data. I think show undeformed shape. Okay, so let's check it for this foundation. Okay, I think here. Okay, okay, I think we are doing it for this one. Okay, so I think this one, it's 403.40. Okay, so we are getting 403.40. Okay, and size we are I think we have taken size as like about, you can draw the dimension also, it's 1.6 and it's about 1.8. Okay, so it is 1.8, 1800 and 1600. Okay, column column size is same. Okay, and it's 403.4. I think depth it is 400. I think depth is 400. Okay, so you have to select the depth also. So here you can see we are getting bearing pressure is around 61%. Okay, and punching is about 29%. And here we have to check the bearing pressure. So let's select the bearing pressure. Okay, and let click apply. Okay, here you can see we are getting 150.19. Okay, it's about 150 at the, it's 150.19. Okay, so here we are getting 61%. Okay, so we have to calculate in percent this. So let's open the calculator. It is 150.19, 150.19 divided by 235. So into 100, you can see it's around 63% we are getting in safe. Okay, and here it is 61% we are getting. Okay, so now you can see the punching is 29%. So why we are getting less punching here? Because we are only checking in dead load plus live load in the Excel. So here you can see the punching is about 50%. Okay, because there are additional moment is there in the safe. Okay, you can see in the 3D, and let's check it here. uh, you can see there are moments also. Okay, Moment is due to the earthquake load and wind load. Okay, there are moment also, that's why it's more. If you want to check in the dead load and live load also, so you can do that also again. So let's select punching and click here and click right. 1 minute. Okay, so you can see this result. Okay, and let's select the dead load plus live load only. Okay, let's select 1.5 dead load plus live load. Okay, and click OK, and we are getting is 0.39. Okay, so here you can see it's 29%. It's only dead load plus live load. Okay, so we have to multiply it with the 1.5. So what you can do, you can multiply it by 1.5. So let's 1.5 multiply by 4 403.4. Okay, it's 605. Okay, so you can see it's 42%. Punching is about 42%. Okay, and here it's about 0.39. Okay, so there are not much differences there. Only 3% difference is there in between manual calculation and the software results. Okay, so that's how you can like do the design. Okay, you should be like you have to do the design cost effect. You have to be ensure that your design is cost effective. Okay, and you have to check everything. Your deflection and your SBC should be around like like 10% or 20% below the permissible limit. Okay, you have to ensure everything about that. Okay, and you have to check reinforcement also, that your reinforcement you are getting is about 1 to 2% in foundation. Like around 1.5% is cost effective, otherwise it will be over reinforced. So we will check the reinforcement in the next class, and for now it's I think that's it. I think uh, I have given you a good idea about modeling today. Okay, how you can merge the areas, how you can reduce the sizes, how you can increase the sizes, how you can combine the different slabs also. Okay, fine. I think for today it's done now. Okay, we are uh, yes, we are stopping the class right now, and we will discuss another checks in next class. And thank you so much.